uh, Anish.
If
Then Charan.
If Charan has to send Anish a
Okay, okay.
digital signed
Okay.
message, then Charan has to send public key.
No, no need. Charan will uh, encrypt using his private key.
Yes.
Is it? Then he will give the encrypted data to Anish. Then Anish will use his uh, Anish will then um, wait.
Yeah.
Anish will use Charan's public key to decrypt.
Hmm. Okay. Right.
Uh,
This
then
this step is known as
authority, authorized,
no no
asymmetric digital signature.
no. That's right. That's right. But what is this
Yes.
step known as? Where we
So,
use what we do in digital signature. If someone has sent me a document or a file, what I'll do to make sure that this person is an authorized person, an authenticated person.
oh,
Verification,
okay.
right? You will
Verification.
verify me. You will verify me with
Okay.
my public key.
Oh, okay. So this step is
Yeah.
on verification step. A digital signature
Yeah.
verification.
Yeah, digital signature has to be verified. Okay. I
Yes.
told you we made a diagram yesterday. So it's verification. Right?
Okay. Wait, 1 minute.
Okay. Then tell me what's the most widely RA, what's the what's the digital signature standard and which algorithm is based on digital signature standard?
Uh,
Um,
R RSA.
okay. And what is digital signature standard?
Uh, this signature. It is mainly for the authority of the message.
No. Okay. Digital signature is for making not authority, but for
Okay.
authenticating the person.
Authenticate.
I don't
Yes,
know.
that. Sorry.
But
Sorry.
what is
That
digital signature
keyword.
standard? What is the standard? What is the digital signature standard?
It is confidential message.
No. I mean, I'm
Stand.
asking, what is
Yes.
digital signature standard? Standard. What do you mean by standard? Acha, you told me yesterday ISI mark. What it is?
Okay.
What is it? What it is? What is a ISI mark?
It's the proof quality. Like
What does it show?
it is valid. So
Okay.
it is
Yeah, it's a valid and it's
not fake.
yeah, not fake. But how do
Oh,
we classify them? For example, there could be various organizations like ISI. Okay, one can be
okay.
fake. For example, I introduced my own mark known as MAN, and I gave this to company, and company just made their stamp of my company MAN. So
Okay.
does this work? Suppose you buy a
Uh,
product where you see MAN is a signature, or a MAN is a mark.
Oh, okay, okay, okay.
So you could, so do you know about this MAN? Have you heard about this MAN before?
No, man,
You
which
haven't heard
product it
about it.
has?
So
No,
what
no.
is it? What why only ISI mark is important?
It is authority of.
No, again
Oh,
authority. No, it's
why
not
is
about authority. Yeah, it's a regulated authority, right? Only
okay,
ISI can do this marking.
okay,
Okay, so what does
okay,
it call? It's a standard.
okay, okay.
It's a
Standard.
standard used by everyone. See, when we use standard, all the companies in the world are on a same page because and we the people who are the common people will get to know about, yeah, the product must have a ISI mark, which is a standard, and every company has to make sure that they are having this ISI mark, which is a standard.
Oh,
Okay.
okay,
For example, in measurement, we have kilometer, meter, centimeter, because these are the standards.
okay.
Okay. Earlier humans calculate center by this one by measuring anything from hand, if you remember, right?
Earlier, uh,
Earlier time, suppose
okay,
I have to, calculate the size of this copy. So how I'll just do it? For example, from this index finger to my thumb. So I'll just calculate,
okay.
yeah, this is the size of it.
Like,
The
take
one
inches,
palm is
like,
the size of it, 1.5 palm is the size of it. For example, wait, I'll just show you.
oh, okay, okay, understood.
One palm, and half
Oh,
palm.
oh,
Okay, but this is
oh,
not a standard. Everyone
yes,
has
yes,
their own hand size, right?
yes, yes,
So
yes.
this is not a standard. But kilometer, meter, centimeter, millimeter, these are all standards. And this is why there's a standard
Oh,
for digital signature so that everyone in the world, sorry, everyone in the world uses that same digital signature standard to have their own digital signature.
oh,
And for that, we uses RSA cryptography, RSA crypto system, or RSA, yeah, asymmetric cryptography. Okay.
okay.
Okay. So now today we'll see about the concept of we'll see the concept of hashing.
Okay.
So I have discussed this topic earlier, the hashing. Do you remember it? Anything of it?
You just mentioned. I didn't remember in detail. You just
Yeah,
mentioned
I
some
didn't mention the details
topic.
of it. Yeah, but I mentioned the useness of it, the use case of, or the
Okay.
why we use hash. So tell me if you remember.
I think it is a part of encryption.
No,
Uh,
encryption and hashing is different.
Sorry. Is it?
And
Okay.
I'll
Okay.
tell
Okay.
you, it is different. Encryption and
Okay.
hashing
Okay.
is different.
Okay.
But I told you, go back to the time when we were learning about blockchain analogy. Remember? Remember?
Uh,
Are you remembering it?
uh, no.
We
No. No. No.
okay. So
I just
Yami,
just heard. I just heard that keyword only. I didn't remember the detail
No,
regarding.
remember blockchain analogy. We are linking the locks with each other, right?
Yes, yes, yes.
So what is
Oh,
why we are why we are linking the locks? Why we were linking the locks at that time?
to find the origin,
To find the
origin of the or
sorry, to
uh,
find the
origin of the
origin.
origin of the where it is start like that.
Okay, I'm not able to hear you just, but I'll just discuss. So hashing is for immutability. Do you now you remember? We
Mm,
were linking locks with each other, and we made a rule that to unlock a lock, we have to unlock the next block. Okay, for example,
oh,
this is
oh,
lock. This is the lock. So we are linking these locks. Now, to unlock this lock, to hack this lock, first you have to unlock this lock, which takes 10 minutes. Do you now remember?
yes,
Or
yes, yes,
you don't?
yes,
So these
yes.
links are are linked by using hash. Okay.
Oh,
So
oh.
what is hash?
To
To
link
link.
between
Okay.
uh,
No,
between
that's
two
okay.
or more
To link the log. But the
or
major use
connected
case
of.
of hash, the major use case of hash is to make things immutable. And how we do that? For example, in encryption, we do encryption and then we can do the decryption, right? It's a two-way
Yes,
process. Okay,
yes,
it's a two-way process. One thing that is in an encrypted form, it can be decrypted, right?
yes,
But here, hashing, once you calculate a hash of something, once you uh, once you put once you calculate a hash of a data, then it is irreversible in nature. You cannot go
oh,
back to the
oh.
data. For example, in encryption,
After use, you just close that after use, close the pen because it will evaporate.
yeah, yeah, you are
Yes,
right. This is how it got dry.
I have used before this writing book. So I will
uh,
after writing I will suddenly close and
Suddenly,
uh,
yes, yes, you're saying right. So, encryption of a text or a message. Okay, you can encrypt text, which is ciphertext,
yes, yes,
and then in this ciphertext, you can do the decryption. You can calculate the data back, the message, the text back to its original form. For example, there's a message hi. Encryption text is KL. Then we can decrypt it and then we'll get the message back. So it's a two-way process. Encryption and decryption take place, okay,
oh,
simultaneously. We can encrypt it and then we can decrypt it, right? But in hashing, it's a one-way process. So, for example, this is a message and we apply hash function. Hashing is done using a hash function. You know what is a function? A function can be x plus y, x square plus y square. Have you read about functions? So, for example, in mathematics, we have seen fx is equals to x square plus y square. Do you remember? Fx, the
Mm,
function of x, which means this value changes with the changing value of x. Do you remember this
oh,
kind of equations in
like
mathematics?
f of x, that is this f of x equal to x square plus y.
Yeah, x square plus y square. Y will be here a constant. Okay.
Oh, okay,
This value changes
okay,
with the value of x changes. Okay.
okay.
For example, f1. If I put x equal to 1, then what's the value? What's the value?
Uh, 1 square plus y square.
1 plus y square, right?
Yes,
1 square plus y square. 1 square is. Now what's f2?
4
What is
y
f2?
square.
4 plus y square.
Oh,
So you see, for every function of x, for every value of x, we have a different value, right? So
okay, okay.
this hash function. We use mathematical algorithms to calculate the hash of something. So there is a message, and we do the hash function. Then this hash function will create this message into a fixed size arbitrary value. And how does it look? Arbitrary value. For example, 0, x, 1, 2, 3, A, B, C, 5, 6, 9, D, X, Z, 19. This is how a hash value looks like. It's a arbitrary. It's not a fixed. Zero, alpha, it's a mix of alphabetics and numbers. 0, 1, 2, 3, A, B, C, 4, 5, 9, D, X, Z, Y, 1, 9. But now you you cannot calculate back the message from it. This is why this is known as a one-way function. You can calculate a hash of it, but you cannot calculate hash message from hash. Getting them in?
Okay. Yes, yes.
So we can say this hash is unique. This hash is unique to a message. Okay. This
Okay,
hash is a unique to a message. And now what's the
okay.
use of it? For example, I told you about digital forensics. How we get to know that this document or this data has not been tampered. Okay. For
Mm.
example, this message, this hacker changed this message to a message M1,
Oh,
message 1. Okay. And
okay.
we don't know. We are saying that this is a message only. But in actual, this is a message. For example, there is hi and there is a hello. Okay.
Oh, okay.
Now,
Okay.
then we calculate this hash function. There's another value. For example,
Oh,
C,
okay.
D. E F 1 2 5 B, sorry, A E F 6 9 A B. Now we will compare this hash value with this hash value. If they are
Okay.
same, if they are same, then we can say, yeah, the message is not being tempered. But if it is different, in this case it is, then we can say that message has been tempered. Message is now different. Message has been changed or message has been deleted.
o-
Okay.
Okay.
So this is the
Okay.
useless of hash function. Here, what we'll do is, and you know what's the benefit of using hash function? In encryption, there are various algorithms. Okay.
Uh,
So
uh,
suppose a message is a very big message. Hi, I am Mantavin. And I'm sending this message to Amin. How are you? Where are you? And what you
okay.
doing? So
Okay.
this type of message, when we encrypt it, it's the length of the message, the length of the date cipher text, the encrypted text is the same for it, and it's very
Okay.
large.
Yes.
For example, hi,
Oh,
I'm Mantavir, blah blah blah. This is of 64 bits or 64 1 MB or 2 MB.
oh, oh,
Then
oh.
the encrypted text will be the same, but in hash function, no matter how the message is, for example, hi message or hi, I'm in Mantave, how are you, where are you? The the result, the fixed size value will be the same. Will be the same. Suppose this message is hi. Suppose this message is hi. Then the value will be of the same size 1, 2, 3, 4, 5, 6, 7, 8, 9, 10,
Yes.
11, 12, 13, 14, 15, 16. Oh, wow. Coincidentally, there are 16. There are 16 bits in a hash. So this is a hash of 16 bits. So high will also have a size of 16 bits. Okay.
Yes.
Now, suppose this message is forget this case. Forget this case if they are not if they are similar. I'm taking another example. Okay. This
Oh,
you got it now. We do this for verifying
yes.
that the
Yes.
data is valid or not. Data has been not changed or not. Now example messages. Hi, I am Mantavya, blah, 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 blah. This type of message will also have a hash which is of same size as 16 bits. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this message will also have the hash size of 16 bits. High message will also have a size of 16 bits. So hash function is easy to compute. Okay, because
Yes. Okay.
it doesn't need any size. If suppose
Okay.
scientists say no, we will calculate a hash function that produces a 8-bit message. So for every message in the world, no matter how the what's the size of the message, the the
Oh,
hash value will be the same. Not same, but of the same size. Okay, I mean.
okay.
So
If
this is how,
there will be
yeah.
20 words, hash will be 20 num
No, not
let
20.
character.
16. 16 bits. The size will be same.
Okay. Okay. Like
Yeah.
20 letters. So hash should be 20 letters.
No, 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 no. In encryption, if there are 20 letters, then the encrypted text will also have the 20 letters, right?
Okay. Yes. Yes.
But yeah, but now scientists fix like for every size of the message, the output will be 10, 10 only. For example, high message has only 2 digits, but it's calculated, its calculated hash will be of 10 size. I don't know
Oh,
what it will be. It will look like this: 0, 1, 2,
okay.
3, 8,
No.
10. This. Now, if a message has 50 digits, not digit, 50 characters. Okay.
Yes.
Then
Yes.
then it will also have a hash which is of 10
Okay.
alphanumerical. Okay. So this is how
Okay.
we calculate hash of it. I'll not go into
Oh.
the mathematical
It
how hash. Yeah.
it will be in the form of alphanumerical.
Yeah, alphanumerical or the arbitrary
Okay.
value. Alphanumerical or it's a arbitrary value. Okay.
Okay. Alphanumerical means numbers plus
Alphabets and
letters.
numericals both. Okay.
Okay.
So
Oh,
this is how the function of hash value. Now that we have seen confidentiality, now we have seen authentication, now we have seen integrity. That's the term we use when we talk about the name hash because it maintains the integrity. Do you know what's the meaning of integrity, Ami?
integrity. No. 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 I don't.
Okay. So I'll take an example. Suppose you and me are having a conversation on WhatsApp. Okay.
Oh,
I'm sending you hi. You are receiving the hi. We are the two authorized persons here who are communicating with each other. Now, an unauthorized person, name it Charan, can see our message. For example, I send you hi. So he can also
yes.
see that message hi. Then this is the breach of confidentiality because he is able to see it, right?
Oh. Oh. Oh.
Now, authentication, digital signature is really Mantav is sending Amin a message. Okay, that's
Okay. Okay.
authentication. I am an authenticated person who is sending a message. Nobody else is impersonating me. For example, Charan is saying, yes, I am Mantavya, and this is the message. So he is impersonating me. He is taking my identity to chat with you. That's breach of authentication, not a breach of authentication. But here the authentication is not done. You are not able to see, yeah, this is the message from Mantavya. Okay.
Okay.
Now, suppose with the ability to see the message, which is the breach of confidentiality, now Charan can also change the message. For example, this have you wrote down?
Yes. Yes.
Okay, okay. So yeah. So the first case we have seen the confidentiality where this is Mantavya. Okay, and I'm sending you hi. And this is Amin. Now Charan, who is not an authorized person, can also see this message hi, which is breach of confidentiality. Okay, confidential. It's
Okay.
confidential between us. It's confidential
Okay.
between Mantav and Amin. Okay. Now, what is integrity? Suppose this is Mantav and I'm sending you a message hi. But this message has been reverted to Charan. And now Charan sends the message hello. Now you see that's the now Charan is all has also the capability of changing the message, which means the integrity between the Mantav and Amin. That uh, integrity means when you broke someone trust. Okay, there's an integrity between you and me. Amen. That say all the communications we are having must be between us and nobody else is talking instead of me. That's confidentially breach of confidentiality. But also that person can also change that message. Then we say it's a
Oh,
breach of integrity. Integrity.
oh,
Getting I mean,
yes, yes.
nobody else
Oh,
can send you data or delete that data or change that data
oh, yes.
except the owner of that message. Okay, so I'm sending you hi, but your Charan is says uh, changing that message to hello and sending to you. Okay,
Oh, okay.
wait. This is the second example. Na? So I'll just write here. Amen. And the message is hello. And how he is doing it? He is impersonating me. Charan will say, I am Mantavya.
Oh, oh,
So this is not
indirect.
authenticated not authenticated person.
Oh,
So you will see, yeah, Mantavya send me hello. Okay, Amin.
yes. Okay.
So this is the breach of integrity.
Oh,
I'll just write
okay.
the breach of integrity. It minor difference. Confidentiality means someone can see your message. Okay. Or I mean, you are
Yes.
sharing your information with others without my permission. That's the breach of confidentiality, right? And breach of
Okay.
integrity, where you have also the ability to change the message. Okay. Here to see the message, just see, just see. You can just see the message. Hi. But now you have the ability to change the message. Then it is integrity, breach of integrity. Okay.
Okay. Okay.
I'm not able to close it. It has just opened.
Oh, oh.
Why it's not closing?
Uh, I think it will pop down.
Okay.
It
Close,
like
close,
pop.
close. So, have you drawn this? It's not
Yes.
of use, but just write it an
Oh,
important note. It's different from hashing. It's just an example. What is the meaning of
oh,
confidentiality and meaning of integrity and how they are breached?
oh,
Okay.
oh.
So this is how the integrity is maintained in internet world and also in the blockchain. Now suppose now suppose
Yes.
now suppose there are written.
Yes. Finish.
Okay. So I'll now explain how does it work in blockchain.
Hashing is done using any algorithm or uh,
Yeah. There are algorithms known as SHA algorithm. It's a standard. It's a standard for hashing. It's known as SHA. It has its own version 256, SHA 5112. There is an also an algorithm known as MA. No, MD. No. Yeah. MA. No, MD. MD5, yes. MD5. These are the standard algorithms when we use for hashing. I think this is the most secure hash function we use this today.
Oh, okay.
Okay. And it's the size of message 256 bit size hash output 512 hash bit output. Okay. So this is the size of the
Oh, okay.
sharpen hash function. So these are the examples of hash function, the
Oh,
algorithms for hash function. Okay, written.
yes.
Now suppose what if we connect now, blockchains are connected with each other like this. These are the blocks. Okay.
Oh,
Now look carefully. Now what we'll do is we'll calculate each block hash. We calculated like for example, I mean I'm sending you a
uh,
Word document. Okay. What is my Word document say? I am Mantavya. Okay. Now, what a hacker did is he opened my document and he just entered the press and he entered the space button and just undo the. So there's no change in my data. There's a no change in my data, but its whole hash value will be different by just simply pressing the space button. The whole hash of the document will be now changed. Okay, I mean, this is the power of using hash function. And this is in digital forensics. We used to present the evidence in code because code needs accuracy in evidence. Okay. And how this
oh,
accuracy is provided? By using the hash function. Okay. So we compare, we
oh,
say to the code that this document hash function matches and never
oh,
changes. So we can say there's a no change in this document. So this document is of accuracy. You can make it admissible and valid in your code for the evidence. Okay, I mean,
oh,
getting. I'll show
yes.
you an example tomorrow. I'll just download a software, hash algorithm software, and I'll just show you how does it work.
Oh,
Okay.
okay.
So
Okay.
we calculate each hash. This is hash 1 because this is block 1. This is block 2. We'll calculate hash of it. This is hash 2. This is third block. We calculate its hash 3. This is block 4 and this is hash 4. Okay. And there are various blocks. Okay. But wait. Now there's a twist. There, how we maintain the integrity, we'll store each hash in the next block. We'll store each hash to the next block. We'll store each hash to the next block.
Oh, okay.
Okay, now look it carefully. What I told you is if the data is changed, the whole value got changed. For example,
Yes.
suppose hacker wants to hack the block 2. Hacker wants to hack the block 2. Now what we'll see is, oh, for hacking the hash, for hacking the block, first I have to decrypt third block.
Yes,
right?
yes,
Because
yes.
because the way to the way to block 2 is by the block 3. You cannot directly access 2. You have to go to
Yes.
by following a path. And what's the path? For hacking 2, you have to reach first at the 3 block. Okay, so hacker seen, yeah, I will go to the 3 block. No, 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 wait. There's another block linked to it. So I have to go back to the 4th block. And then you'll see, oh, there's no block now. After 4, there's a no block now. So I'll just hack it from now. Now, now, now this hash, now suppose, now suppose he is on the hash 4. Now, once he hacked this hash 4, this hash 4 will be changed, right? It will be changed because he
Yes,
is
yes.
now changing the data and have the block. Okay.
Okay.
Now he will reach to the 3rd block. Okay.
Okay.
Now,
Okay.
once he'll get to the 3rd block, he will change the data. Now, hash 3 will be changed. It will be a something
Oh,
new. Okay.
oh,
Now it will take around 20 minutes, right? I told you we are implementing the system
oh.
where there's a time bound. The hacking or the deletion or any change in the block takes 20 minutes. Okay. Now suppose we are the miners. Charan, me, you, okay, Anish, and Mujahidul. We are the we are the members of this blockchain, so we can see everything on it because we store. I'll just tell you when we are learning about blockchain in depth. So now we are working on a new block, for example block 15, okay, which will take only 10 minutes. Okay,
Okay.
now
Okay.
once the 10 minutes is completed, we'll go back to the network and see, oh my god, there's something mishappening in the network. Someone has changed hash of the 4th
Okay.
block. Someone has changed the hash of the 3rd block. So we'll compare the new hash. For example, there's a new hash changed.
Okay.
I'm just naming the new hash. So we'll compare this hash with this hash and say, oh my god, there's been a tampering in the network. There's been a tampering in data and blockchain. So what I'll do is I'll just remove this data from the block so that the hacker cannot reach to the block 2. Getting Amin? And
Okay.
I'll put
Okay.
3 and 4th data into a new block. For example, in block 15, I'll put block 3 data, block 3 and 4th
Okay.
data in block 15. Okay, Amin? Getting?
Oh, okay.
So
Yes,
this
yes.
is how we maintain the integrity in blockchain. Okay,
Oh,
uh, that's why we say that in blockchain it is immutable in nature. Getting Amin?
oh,
Because
yes.
hacker has to decrypt it within a time which is 10 minutes, but he's taking 20 minutes. Okay.
Oh,
So this is how we maintain integrity in the blockchain. So nobody can change the data. Okay, Amin?
yes. Yes.
Okay. So I'll just draw the diagram again and you or have you drawn it?
Yes, I have done.
Okay.
Yes.
What's the time?
It is 8:55.
Okay. Okay. So this is the basic concept of hashing. Okay.
Okay. Okay.
And in a block,
Uh,
no, that will be of very depth. When we learn about blockchain, then we'll see. Okay.
if there is a five block, so it should
Yeah.
start from fifth block to open
Yeah.
third block. Okay. Okay.
Yes. So it's very difficult for the hacker to hack. Okay. For example, now Bitcoin have total of, check in the Google and see, type it, how many blocks a Bitcoin have currently. Just
Oh, oh.
Google it and let me know. Have you seen?
No,
No? Just type how many blocks Bitcoin have currently. How many blocks have been formed?
how many
Blocks. Or
blocks?
how many Bitcoins have been released till date? Wait, I'll just check it.
Uh, 1,000.
1,000.
Is,
It's
how many?
no. There are,
What?
this reward is halved every 200 until 21 million. No. It's slated to end around 200. It's currently one nine one ten hundred thousand 10,000 lakh crore 10 crore. It's 19 crore 7 lakh 79 lakh. No, 7 lakh 92,700. 1 lakh
Okay.
1 lakh 90 90 97 lakhs. No. 1 lakh 1 crore 9 lakhs 90 lakhs 7,000 and 92,700. Yeah. And how many are left? Only 1 10 100,000 10,000 lakh 10 lakh. Only 12 lakh 7,300 are left to mine. Okay, I mean,
Okay.
so this is how
That's
a blockchain works. So for example, I told you there are 19 over 1 crore blocks. For example, has to hack. So he has to perform this hacking from the last block, which is 19,792,700, the last block.
okay.
It's very time consuming.
Okay.
So that's why we say Bitcoin is very secure in terms of
Okay.
security and technology. But if you talk about the use of it, then it's widely used for terrorism and illegal purposes,
Okay.
right?
That is,
So that's a
yes.
different. It is secure, and that's why these criminals use it. Hmm. But it also unsecure for the common people like us because we can get scammed on a daily basis, right? I mean,
Okay. Yeah. Yes.
yeah. So it's subjective. We are not secure on blockchain. Sorry, on Bitcoin, because there are various unwanted entities like criminals and all who are uh, who are always ready to scam us. But on a technical point of view, it's the strongest and it's the most secure technology we have. Okay, Amin.
Okay. Okay. Okay.
I think we are good to go now. And
Yes. Yes.
You have to go to office. You have to get ready. So you do your breakfast and then go to the office.
No, I have to go to canteen. Then only
Okay.
uh,
So what's
I
the
I
place? Yeah.
I have to ready and I will go to canteen. Then from there I will go
Okay.
to
You have to eat it. Okay. Okay. So Amin, where do you live now? Where's your office? Like the city?
this Kerala, Trivandrum.
Trivandrum.
Yes,
Okay. And where you originally from? Where's your hometown?
I'm from Kochi, Kerala, Kochi.
Okay, you're from Kochi.
Yes,
Okay. So how much time it takes from Kochi to Trivandrum?
5 hours.
Okay,
I
5 hours.
only go monthly 2 times in month. Saturday
Okay,
also
okay, okay.
working, so I only go
Oh,
home.
okay.
Yes, I only go home monthly two
Yeah.
times.
Okay,
While only
okay.
taking leave, two leave only I take.
Yeah. Okay, that's nice. That's nice. So you are enjoying your work?
Yes, yes, okay. I love to study more technology. So
Okay, okay, okay. Yeah. That's nice. So you live in a PG or a flat?
no, I have PG single room.
Okay, single room. Okay, okay, okay. Okay.
Okay,
And
okay.
how's the weather there in Thiruvananthapuram?
Here now rainy,
It's not raining there?
rainy. Now it is
Oh,
rainy,
it's rain. Okay, okay.
wet.
Okay. And how is the maximum, what's the maximum temperature there in summer?
Here that really 23, 20. That really I didn't know.
Oh
Summer
my
I
God.
think uh,
Yeah.
uh, this it is 30 above.
Oh my God, only
Yes,
30.
30
That's
above.
very nice.
Till
So it's so
till
Thiruvananthapuram and
40
South. Yeah.
till 40 till which I don't know the correct. It is according to the in some in some other district it will be high 45, 50
Yeah,
is it.
45, 50. Yeah. I think in
Sunburn had
Chennai we
occur.
have 45 degree.
Chennai
So
it is
yeah. So how? Yeah.
different heat. It no
Okay.
heat I
Yes.
think
Yes.
so, but it
Yeah.
the
It's because due to pollution and everything. But what about
yes, yes,
Thiruvananthapuram? Did this city have um, uh, you know greenery a lot? It has a greenery, and
yes,
how it is?
yes.
Okay,
Green
okay,
it's there's greenery here.
okay, okay. And what about
People
Wayanad?
and
Where is Wayanad?
Wayanad is in northern part of Kerala.
Okay, okay, okay,
Uh,
okay. So it's
uh,
a nice place. I thought. I think, but there's a
yes, yes,
tragedy came there, a flood.
yes, landslide had occurred. Yes,
Yeah, landslide and all. Yeah.
because this water will store in the these mountains. When rain
Yeah,
came, the mountain water and rain will uh, both of them make problem. So because of that,
exactly. Exactly.